In this lecture, I'm going to show you how to create a Morse code generator. So this is going to be a simple application on the circuit we built, the Hello World circuit, even though this is a simple circuit with an LED, but we can already, do something about it. And so not just light it on and off, but we're going to actually do something meaningful. This will be using Morse code. And what is Morse code? And Morse code is actually a way to communicate. Um, it's the sort of the original text messaging. And this communication relies on transmitting an alphabet, and each letter or character is constructed from dots and dashes. They're called dots and dashes. Dots and dashes are more of just a visual representation. And how are we actually transmitting the dots and dashes? We'll see in a second. So the Morse code, so the dots and dashes, they are basically a simple mechanism to represent the characters in the alphabet. And it's like an encoding. And the encoding, instead of the numbers, what you would know from a Unicode, and here we're using so-called dots and dashes. Now, the reason they're called dots and dashes is because the only difference between dots and dashes is basically the length of the on state. So logically, you have an on state and off state. It doesn't matter how you transmit that signal. So you kind of have this logical two states. It's like a binary state, and you have on and off. So, and you would use two forms of on state. So when it's on, for a certain period of time, they say that's a dot. That's the, unit of signal. Then you may say, well, I have a dash. The dash is longer than the dot, typically 3 times as long as a dot in terms of how long that signal stays on. So then you would combine this, signal based on the length, based on the duration. You have a dots and dashes, and then use the dots and dashes to encode the alphabet. And then when you're transmitting like a word, each character, each letter will need to be separated. There will be some kind of gaps in between so that this group of dots and dashes is finished or represented in one letter. So there will be the gaps or spaces in between, and they are represented with the off state. So you would have 2 states for however you're transmitting it. So in our case, our example, LED, when the light is on, that's on state. When the light is off, it's off state. So you would use the off state to fill in the gaps between the dots and dashes and also the letters and the words. But then each letter is represented based on the dots and dashes. So there's, based on a different duration of on state. So the actual signal can be represented in multiple ways. You can say, well, I'm going to use electrical pulses along a wire. And this is the original telegraph. This is how the Morse code was used. It was sent over the wire via the electrical pulses. And then you may also use an audio tone, some auditory device, like a drum beat if you want. And you may also use a radio signal. Obviously, there's the wireless way of transmitting. This is probably how it was done, like during the World War, and the military used, the Morse code devices to send a message between each other. And with that radio signal, then you can send short and long pulses, the dots and dashes, right? And of course, you can use the mechanical method or visual signal, like a light tower, for the navigation on the ocean, in the old days. and you would have that light. You can use that light to, when the light is on, that's the on state. You can, depends on duration, you can, then you have dots and dashes, so you can simulate that way. And then you can light turns off. This is exactly the kind of situation where we're using our LED circuit, except that's a mechanical method. Somebody operates the shutters on that light, the big powerful light, and then kind of turn the light on and off in that way, for example. Yeah, or you can use a flashlight. So who invented Morse code? The Morse code was named after this guy, the inventor, Samuel Morse. So he pretty much grew up in the 19th century. And during when he was in his 40s, well, he actually has been a painter during most of his life, and he painted over 200 portraits. And so basically he was an artist. He was not very wealthy at the time, and he didn't kind of struggle to feed his family. And then so he was looking for ideas, and then on a trip to Europe, and so he got acquainted with some people and talked about that was the period of time, if you recall, in the sort of the second half of the 19th century. That's around that time there was a lot of invention about electricity, electromagnetism. There's a confluence of inventions around electricity. So it was just the proper time for that thing to be invented, actually. So he came up with this idea of transmitting messages over the wire with this electromagnetic mechanism to bring the messages. Actually, originally he came up with the idea to punch the holes on a piece of papers that represent the letters that was transmitted over the wire. So in 1836, he actually came up with a sample of the telegraph. And then next year, he actually invented a telegraph, and that was basically, was a working prototype. And then he actually patented in that year what he was inventing. And then the following year, he actually, so originally he used numbers to represent the letters. And there's need to be a translation, kind of is not convenient. So he improved it by changing the numerical code to presenting the letters directly. So it's just cutting out, another indirect translation. And so this is actually this picture shows, if you look closely, and this is kind of the mnemonics or the visual guides, how to, the people can get trained in Morse code. They can actually, the dots and dashes, right? This is actually using the dots and dashes represented for letter A. Yeah, but it's represented with a 1 dot and along a dash. So in the way to remember this, and typically they will say this, the dot is called a dit, and then the dash is called da, so it's dit da, and then B is basically da dit dit dit, right? So this is it's a system to help people remember Morse code representation of the characters. And a couple years later, he got some grant of like $30,000. At the time, it was a lot of money. He sort of built the wires from Baltimore all the way to Washington, D.C., and tested sending a telegraph. That's probably the first telegraph that was sent. Message says, "What hath God wrought?" That was a famous message that was sent, and to Baltimore. So that was successful, and then later on, his device it was used for transmitting other messages, and it was very successful. So he came up, and then he incorporated his company, and then sold basically his invention and his patent, and he collected royalties afterwards. He became very successful. financially. So how is the Morse code used? So the way in the early 1890s, the radio communication was using Morse code to transmit messages, and of course was later used in the navigational radio beacons, and then the amateur radio operators also they love the Morse code and they can transmit messages that way. Now, at the time, what the radio wasn't really that sophisticated, and the mechanisms, transmitting audio data wasn't quite there yet. So this was the early text messaging system, and then it has evolved over the years. So initially, in 1848, there was a bunch of changes that were, for example, additional letters were added or even punctuation, and then became the International Morse code. And then the original code then was called the Railroad Code or American Morse code. And that is nowadays very rarely used. Everybody's using the International Morse code. That's which includes not just the English alphabet, but also some extension, the sort of the Latin, additional Latin characters are included in there. Now, for Eastern languages such as Chinese or Korean or Japanese, though, they have their own, even Russian, they have their own variation of the Morse code, by the way. So that's pretty much it about Morse code. I wanted to introduce that first. Okay, and let's see how we're going to use this. Now, before we get to programming the Morse code, and then if you read the book, we're gonna the idea is that we're gonna define a class. So in the previous review of the Python programming, I did not introduce a class. So I'm gonna do a very brief introduction of the class, and so just help you review, and hopefully you actually have already studied this, and this is not very much a new concept to you. All right, so I borrowed a couple of slides from the book, chapter 9, that I introduced you to, just help you review some of the other basics of Python programming. So let's go through a couple of slides here. Now, Python is a very much object-oriented programming paradigm, and everything in Python is an object. It's a little extreme. Many languages are not like that, but Python is designed to be fully object-oriented. So, before you design your own classes, I mean, you have used many classes from the library, so you're already using them. Now, of course, if you can't make your own, that's, you're not going very far with your programming. So the idea with the objects and classes that you usually want to have defined an interface of the class, like what are the things that you can do with those objects once you have instantiated objects, and then what is the state of the object? Like state means what attributes, what variables that the object are associated with, and that we have the object has data. No. Well, not necessarily every object has data, but you can have data objects or non-data objects. But typically, let's just say that the objects we're going to encounter, most of them will have some kind of data that makes this object somehow unique. Okay, this represents something. There's a state about the object. And then how do you actually make an object? So this is just basics how you use the relationship between objects and classes. A class is basically like is an abstraction of the objects. These objects are made from a class, and a class is like think of it like a template. Okay, you're using that template to make various different objects, and the objects are the concrete objects, and then they're made from the same class. So they may have different attributes, different state, but they're going to behave the same way. Behave in the same way means they have the same kinds of methods. And we'll look at a concrete example shortly. So objects are abstractions the package state and methods in a single entity, then you can reference that through a name. And a class definition is like a blueprint. So as I mentioned, it's like a template or blueprint, and it contains definitions or methods. And the methods means those are like basically they are the functions, not the free form functions you define without a class. These are also functions, but then functions defined inside the class. They are meant to be invoked on objects of the class, but not as a free form function. So these functions that belong to a class, they're called methods. Then you may also have description of the data structures used that maintain the state. So there is an example of a student class. So let's actually switch to the code. Take a look at the code instead. It's easier to look at the code. So let's say you're designing somehow some kind of a course management system. In that system, you probably will have a class. Yeah, let's say you're using object-oriented programming, your object-oriented paradigm to design your system. Then in the system, obviously you would have something that represents a student. So you have a class called student. And now the naming of a class, typically it's convention. So when it comes to programming, you have to learn a lot of conventions. It's not about what you can do according to the grammar, what is valid, but it's about what is usually done, follow those conventions. And Python is a very much convention-based language. So for our class names, typically we'll want to use a, capitalized words. If you have multiple words, there's no space. So each word will have the initial capitalized. Then the very first thing, typically you'll know for any class, the very first thing you want to figure out is how do you instantiate an object for this class? So you would have something called the constructor. This is basically the constructor in Python. And it's called the init method with the double underscore before and after. So whenever you see a method name that has double underscore before and after, there's more than just init, there's more. Those are the special methods defined by the programming Python language that they have special purposes. And so you want to use them according to their own purpose. So this init method, the purpose is to construct an object for your class. Now the very first parameter is always going to be called self. Well, you can use any other word, but again, convention, call it self. This will be the object that you're trying to construct. You get a reference to it. And so when you, then you may have other arguments that pass in, let's say student name, and this number here, actually just the number of scores that we want to store, test scores. And over here, you notice that we're actually, assigning this name to a variable here. This variable on self dot, and it's okay. So we have not defined anything. Where is this self dot underscore name? Well, here we're actually making a new. It's called an instance variable. Instance variable means this is a variable for the objects or instances of the class. So it's going to be different for each object. So this instance variable, I call it underscore name. Now in the books or many places you're going to see, they are a lot of places they don't use underscore. Now I like to explain. It's a good idea to use the underscore. Again, this is a convention. When it's underscored, means that variable is basically not for public consumption, it's private. In Python, there's no accessibility modifiers like private or public or protected. There's no such thing in some languages that if you have used like Java or some other language that you, or C++, you may be familiar. There's all those things. There's a modifier or the access specifier for who can access what. Python doesn't do that, so it's more of just naming convention. That's really what Python does, naming convention. So underscore, uh, you know, there is no good reason when it comes to class design, no good reason to have a verbal, instance verbal that's kind of a public for kind of open for modification outside. You don't want that. So the idea is that your class is self-contained, and if there's anything needs to be changed, it needs to be changed through the methods, not directly on the instance variables. So this is so I'm just kind of telling you this is sort of just good thing to do by default. Just indicate they are private, and then we have another. Say we're gonna create another instance variable. This is kind of a for some languages, and it seems a little strange, but this is just how it's done in Python. And the whole idea of a Python is try to simplify a lot of the sort of the blow of the language features. And I mean, it's kind of got a smaller set of features and then intended for easy programming, right? It's got a that usability top of the mind. So we'll make another instance variable, initializing it with a empty list, and then we're actually going to initialize it with just make all those things 0. Then we're passing this number, say, oh, this is the number of scores we're storing, and then we just by default initialize all of those scores as 0. Not necessarily super necessary. It's just it's the example from the textbook, but with some modification here, like the underscore. The method names, in Python, the naming convention typically is lowercase, and then you can separate multiple words with underscore. You'll notice the standard library, the methods that you may be using, they may not even use the underscore in many places, but I think underscore is a good idea to separate the different words, make it more readable. So again, just convention. So get name is to get the name. So you return this variable. Now, yeah, this variable we have already set, right? So this is from the initial construction. And later on, then we may call this on the object. And then by the way, the first parameter of the methods, it's going to be always self. This is equivalent to the this pointer in some other languages. So this will give you access to current object that's you're operating on, right? So then you simply just return self._name, and then you can change the score at a different specific index. Then essentially you just operate on that list, right? There's nothing special here. And then you may say, oh, I want to calculate the average, so I use this sum, the sum function. This is from a standard library, Python, and add up all the scores and then divide by the number of scores. And you may also get the max. Now there's another special function, right? Special method here. This special method is the string method. This returns a string representation. This representation typically is the informal representation. It's not the representation that you can actually, is not intended for, let's say, serialization or deserialization. Sorry, I don't want to get into too much into that, but if you know what they are, kind of the difference I want to just show you. Then there's this another special method that are, representation or REPR for sure. And that is the one that's for sort of the formal serialization kind of a format. But this is typically for just informational, for debugging, for printing out what the object is. And so this string representation, this is typically used for debugging mostly. And so here's what I typically do. I put a class name here, and then with the curly braces, and then inside. By the way, this is an F string, right? So I've introduced you to the F string. So for string formatting, you should prefer this in most of the times. You know, in F string, you have those placeholders, you use curly braces, right? Because curly braces is special. And if you do want a literal curly braces as printed out, then you want to use double, right? So this is how you get a literal left curly brace. So we just, you know, put in the state, we'll print out the state of the student, and then he has a name and scores. And when the scores want to transform that list a little bit, you don't have to. I think the default might be just fine, but let's just say you want to transform it with separating the values with a space, and let's use this join method on this on string. As an empty string, you use a join on this thing, and join what? Join a you know, you kind of transforming that scores, which is a list of integers, right? List of integers, and we need to transform them to strings, you know, to do the join. The join can only operate on the iterable of a string. You see that? So you have to transform that. How do you transform? Use this map function, right? This is the standard function map to do that. Okay, so for testing purposes, so we create a object of students, and they instantiate it with name, and the number is how many scores are going to be stored there, right? And then I'm going to just print out the s print. When you just print s, this is going to, by default, is going to actually call this string, the special string method. The string version, this will be actually used, and you'll see this will be printed out using this. And of course, just showing you the other methods you can call, set the score, and then print the object again, and then we'll get the high score, average, first score, and name, right? All these things, just gonna test this out. So let's run this thing. And so just, okay, here you go. Let's make this a little bigger. So we just ran this as you see, this is how we implemented the string representation method. And yeah, fairly straightforward. Yeah. Okay. So this is that. Let's go back to slides, see if we have a couple more things to add or not. Right. So you've seen this class definition. The syntax is like this. You have this keyword class followed by the class name. And then you can, this is optional. You can have a parentheses for, you know, with the parent classes in it. It can be multiple. And so we're probably not going to be using the inheritance much in our projects. So we're not using the actual that much of an object orientation. But so when we encounter them, I'll introduce you more to it. But for right now, you don't need to worry about this. And then inside of it, and then you may define many methods that you can operate on the object. Okay. So the class name is typically capitalized. And the pattern class is organized in the tree-like class hierarchy. And this is the hierarchy we're talking about, the inheritance of object-oriented programming. You have inheritance, you have the polymorphism. Those are the typical OOP features that is the same in many different object-oriented programming languages. So this is if you learn one language and then the other one is very much similar, at least conceptually, and then the little difference would be in the syntax and exactly how you might do it in the code. So the doc strings. So I have now explained there's a bunch of places where actually, if I can go back there. So you notice I have sort of a string. These are triple quoted strings, but they're still, you know, the syntax is a string, right? Triple quote allows you to have multiple lines. So this is a string. This string in here just by itself. This is a doc string. This doc string is to document the module. This file is considered a module. And that doc string, actually, you can retrieve it. You can use it. And you can actually access a doc string of a module, for example. The doc string can be also put in a class level. And so but right under this declaration line of a class name, and then you have a line, then you can have a string, okay, multiple lines, whatever, with the triple quoted. And then this is the document, the class, what the class is about, this documentation. So if you hover over this thing, you'll see the IDE will recognize, it will read that string and show it back to you, okay? And then for each method in the class, if your first statement is a string, that string becomes the doc string of that method. So if I hover over this init, it's going to show that word that we just hit, like get name, for example, it will say show get the name. So that's the protocol here. The very first statement, if it's a string, it becomes a doc string, and doc string can actually be retrieved. It's considered a property of that, whatever that entity is. It can be the property of the method, or of the class, or of the module, right? Method definitions are indented, and you'll notice there's the indentation. Obviously, Python is indentation based. It's sensitive to indentation. It's not using curly braces or other ways, other symbols to delineate the different scopes. And so it's using the indentation. So just keep in mind that indentations are significant. The definition of the method, again, they're just very much similar to functions. There's not much different, except the first argument for methods is typically the object itself. It's called self. And self is a naming convention. It can be called anything else, but everybody uses self. When you actually call the method, you don't pass in self, by the way. The self is the object that you are calling the method on. So like if the object is S, you're calling a method get score, right? Now get score, the very first parameter in the definition has a self, but you don't use self in here. You don't pass that at all. Well, get score right here, show this one. So because this self automatically will be passed in by Python as the object S. In fact, S will be passing here, right? So when we access this underscore scores from self, then we're getting that instance variable from the object S. Okay, so you're getting, this is equivalent to many of the languages you have this pointer, if you or the this reference. All right. Now, one more thing I want to point out that is also not necessarily in the book is that it's a good idea when you define a function or a method, you have the parameters, right? The parameters, you should indicate what the type is. Even though it's optional, you don't have to have it. It's a good idea to do it. This just makes it very clear, and it's not like you can just pass in anything, right? This is sort of a documentation as well. So these types are called type hints because it's really not necessarily enforced by the Python interpreter, but nonetheless, your IDE may give you help. In the case of using Visual Studio Code, it's going to actually show you those things. If you let's say you're missing. If you're missing this type hint, it's going to show you, say, well, this parameter has an unknown type. Good idea to get via the type. So just and then similarly, the return type again is optional. Is this type hint is saying, okay, I want to return an int, and then this method here, I want to return a float. So you want to make that, put that in the declaration. Is the type hints. As a documentation, and it's just a good habit to do. Okay, so these are some of the additional things that you may not see in many places that they don't necessarily teach you to do that. So these we have explained about the init and string. So there's this terminology about the getter. So it's in many places, people just call this getters and setters. So if you're accessing the variables, it's the getters are the accessors, or the setters are the mutators. The setters are to change the state. Getters don't change the state; they just read the state. So they're equivalent terminology. That's how people call them. So the rules of thumb for defining a simple class. So this is going to show you what you might usually do when you write a simple class. So you want to think about the behavior and the attributes of the objects. For example, for student class, you want to represent the name, or you want to handle the tests for the students, maybe have a variables to handle the test scores, right? And then choose the appropriate name, and then figure out the list of methods that you want the user of the class to be able to use. And then you write some simple script to actually just test it and make sure it's doing the right thing. Like for example, here we have a main method, main function, sorry, main function, and then if you run this script as a program, you can, and then you're testing the class in a simple way. There are more rigorous testing methods, by the way, for programming. If you do a large scale programming or in a team, you may use testing frameworks like PyTest, for example. And so then those tests are automated and they just run whenever you make a change to the code. That's the more typical software engineering method of testing your code, making sure the code quality is good and you don't have many bugs. But in your typical small, simple programming, you can just have a main function here. And this allows this file to be imported as a module without executing your test code, right? So that's it about introduction to the classes, right? Now to the Morse code. I want to run our Morse code generator. So we have this hello world circuit built, right? Okay, so we can do something more meaningful about this on this circuit. So we can use LED on and off state to send the messages. This is a visual representation of, basically as the light comes on and off, and then that, it's communicating using this encoded message in Morse code, right? So let's say we have a class called the LED Morse code generator. I mean, again, the naming wise, by the way, so I have this LED prefix here because there can be many other types of Morse code generator. Again, so I kind of make this explicit. So this actually depends on LED. You need to have LED to use it. Now, so we have a constructor. Now, constructor, this may be looking a little different from the book. So I want to kind of show you sort of the more proper way. The code in the book is not necessarily optimized. It works, of course, but I want to show you sort of the proper way how things usually should be done. So for example, the private instance variables, just use the underscore. And then in the book, those things are actually defined as a class variables. And these things should not be class variables. Typically, these should be kind of specific to each object of the class. The one thing that can be class variable, so this is the one in the introduction I did not explain, I'll explain it right here, is that you can define a variable that belongs to the class. So you say the class level. What does this mean? This means this variable is shared by all the objects of the class. Now, naming convention again. So the underscore means this is a private. Don't access this directly from outside the class. If it needs to be accessed, it will be through the methods. Then this is all caps. Now all caps means it's a constant. Now it doesn't mean you cannot modify technically. You can, but again, it's convention based. Python is very much convention based. If it's all caps, it means it's a constant. Don't change it. Okay. So this Morse code is a map right here, as dictionary. This dictionary has the representation of the alphabet followed by the value of the dots and dashes, right? This is the Morse code representation with the dots and dashes. Now, those dots and dashes, they are simply just a representation, but they need to be translated into how we're gonna use the LED for it, right? So the key thing is, okay, the dot, what does dot mean in LED? So we'll turn the LED on for a certain period of time. The dash is 3 times as long as that dot. So if a dot is on for 1 second, The dash means is on for 3 seconds. So that's how you differentiate between dot and dash. Okay. So let's go back to this. So we initialize a couple of variables here for the objects. So first of all, we need the LED object. So we're going to initialize the LED object based on the pin number. So we'll pass in the pin. In our case, the circuit, we're using the pin number 18, right? The GPIO pin number 18. And then the dot duration. So essentially, as I said, if the dot can be represented as turning the LED on for a certain period of time, how long do we want to turn it on? Then we say it's a dot. So let's say by default is 0.3 seconds, like 300 milliseconds, and this you can change, you can adjust it depending on how fast you want the Morse code to be shown as the LED, blinks, right? So, and by default, I say I have a 0.3 here. The unit is seconds, and this is good enough. Now, the dash is 3 times of that, right? So that's what I meant. This is by the Morse code specification, the standard this is how it is designed. And then, as I mentioned, that you also have there are spaces. Whenever you finish a letter is represented with the multiple dots and dashes, right? There's multiple those signals you send out. But once you finish a letter, you need to have a space. So the space has a certain duration. That space is represented by the off state, means you turn the light off. Okay. And then you wait for a certain period of time. And that waiting time for a letter, in between letters, that duration is the same as a dash. Okay, it means that 3 times is a dot. And then once you finish a word, and then you also have to pause it, right? Once you finish a word, then pause the off state as 7 times the duration of a dot. Okay. And then let's see how we transmit a message. So let's say we're passing a message in string, which is a string, right? So that's what we want to do. We want to translate that to Morse code, which is, represented with LED blinking. And let's ignore this one for a second. I'll explain this. You have a message, and then how do you do that? So you break down the message into letters. So you have a for loop here, right? I want to transmit each letter. So once we have a letter, then we need to convert that to the Morse code representation, the dots and dashes, and that is coming from that dictionary Morse code. So we use this get method here because let's say we received a letter we do not recognize, it's not in the Morse code dictionary, and then we want to just ignore it. We don't want to throw an error. It's going to be a key error if you use this, the subscript operator. So remember the difference. I explained that a little bit in our introduction. So the safer method here, we're going to use the get method, and so we're going to get the value for the key based on the letter, and then we want to just capitalize it because the incoming message could be uppercase, lowercase letters, right? So we don't really care about that when we transmit the Morse code. The Morse code doesn't differentiate between upper and lowercase. And so because the Morse code dictionary here, we're using uppercase here. And this is kind of the conventional way. And if we do not find that letter in the dictionary, then we just return this empty string. Okay. So if we did find the letter, so we'll find the Morse code representation for the letter, which is the dots and dashes, right? So then we're going to loop through that dots and dashes, and we're going to send the signal for the dots and dashes. So you have a dash dot represented either as a dash or dot. So for each single one of them, for example, letter A is represented with a dot and a dash, right? A dot followed by a dash. So this is how you do it here. And as you can, then you have another loop to check the Morse code. Single Morse code, the letter would be a dot or dash. If it is a dot, and then we're gonna call a dot method. If it's dash, we'll call a dash method. Then there's also space in the messages, right? If it's a space, actually, hold on a second, let me see. So remember, we're actually there's a special mapping here. If incoming we encountered in the message we're trying to send, the incoming message contains a space, you have a sentence, right? If I have a space, then we're just essentially saying the value of that is also a space. So that's why if the incoming was a space, then here in the Morse code representation is also a space. So if it's actually a space, that means we have finished a word. We have a word boundary. So the space is used to separate words. So assuming the income is English sentences, right? So this will be, now we need to signal a word spacing. So we finish one word and then we have some space in between the words. Now, so previously I mentioned that after we finish each letter, we also need to send a signal to delineate or to indicate that letter has finished. So there's a letter spacing we need to also signal. And to signal letter spacing, there's actually a couple conditions here. So remember, if we did not find a mapping in the dictionary for a letter, so we just don't have the Morse code for it, and then we want to ignore it, right? So essentially we'll say this needs to be true, means it's not an empty string, right? So this is the condition in order to say we have a letter spacing, because if there's a letter we don't recognize, it will be ignored, it will continue on. So we have not, we basically will say we're not, let's see, Morse code letter. If we did not find a mapping for it, yeah, we did not find a mapping for it, and then we just ignore it. This is how we're going to ignore it. Now there's another condition right here I'll explain later on, okay? So how do we signal a dot? So remember in our example of hello world, right? We use a blink method. The LED object has a blink method, and then we just use this blink. This is already familiar now. We can turn this on for a certain period of time and turn it off for a certain period of time. I'm also repeating that number of times. And so we're going to turn for a dot, we'll turn it on for that dot duration. And then we'll turn it off for dot duration. So the separation between each dot and dash is always a dot duration. So that's how it is. And then we'll want to just repeat this one time. Okay, we just turn it on for dot duration, turn it off for dot duration. That represents a dot. Now, this dot duration, the off state is to separate between dots and dashes in a single, Morse code representation for a letter. So this is in anticipation of the next letter or word, right? So we're gonna turn it off for that duration. If it's a dash, so essentially we'll say, well, stay on for a little longer, which is 3 times the dot duration, right? So we have, blink, we'll turn it on for dash duration, and the off is still a dot duration. This is for separating between the dots and dashes. Now, if we finish that letter, then we want to give a signals, basically in the off state for a certain period of time that indicates we have finished that letter. So then we use a letter space duration. Now we need to subtract the dot duration out of it, because previously after each dot and dash, we already have used a dot duration in the off state. And this spacing between the letters, so this needs to be accounted for. So that's why we are subtracting this out of it, because we already waited for a dot duration. So the remaining of that letter space duration will finish, and then we're gonna move on to the next letter if there is one. Now, if there's not a next letter, we know then we're separated by space, and then we have another word. So we need to have a word spacing here. The word spacing, we essentially use the word spacing duration, and then we're going to subtract that, the the letter space duration from it because previously we have finished a letter. So it's basically a word space always follows a letter space. And then because we already waited for a letter space, then we just need to subtract that out of the space duration for a word. Otherwise, we waited too long. Okay, so these are the little corrections, and I think the book is not doing that right. All right. Okay. Now, how do we test it? So essentially, we just create an object of this code generator and give it a pin number 18. And then we'll call the transmitter message. By the way, if you see the methods here with underscore, those are not meant to be used, outside. They're meant to be just private. So the only interface to this class is transmit message. So that's the intention. You see the convention based doesn't mean you cannot invoke them, but you should not. So what we're transmitting here is SOS. So with the Morse code, there's probably the most famous message you can send is SOS. That's the emergency, asking for help. And this is the international standard. The SOS is what's called a pro sign, or it's short for procedure sign. And a pro sign is not three separate letters. In this case, SOS is not going to be transmitted as a three separate letters. So that means you should not have a letter space in between S and O or O and S. That's why there's an additional condition here to say if it's not pro sign, then we actually will add a letter space. If it is pro sign, we do not add it. So that's why we're passing additional parameter here. The message you're sending, is this pro sign or not? Okay. So let's actually see how the LED blinks. Now, the SOS, let's take a look actually quickly. S is ... O is dash, dash, dash. So the pattern for this is going to be ... dash, 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 and ... Okay. All right, let's switch to camera. And let's run this program. Now, when you run this program, obviously the same thing. It needs to be on that remote session. So I got the code in the remote session, and just the same way I showed you the last lecture on the Hello World. I'm going to click on Run on Raspberry Pi. Right, you see that? So the ... are shorter on states, and the dash dashes are longer on states. Longer, basically three times as long. And you also notice in between each dot or dash, there's a gap in between, which is the same length as a dot. But there's no letter spacing. There's no waiting after the S. There's no waiting after the O. So that's pretty much it about this Morse code generator. Thank you.